Thank you for visiting my channel. I am the Actuarial Guy. Please subscribe to receive the latest videos from my channel. This is the final part of Unit 3, which deals with interest rates. I would like to inform you that the next video will be a question and answer video where I will select a few questions from the CT1 papers. That's between 2005 to 2012. And these questions are going to be specific to what we have covered from Unit 1 to Unit 3. Now, delta denotes the force of interest. The force of interest gives the total amount of interest payable continuously per unit time, in a case where the amount invested is 1 unit. We can use delta to calculate the instantaneous change in the fund value at time t. What I mean by this instantaneous change in the fund value at time t can be thought of as the interest earned by the fund at exactly time t. Now, if we have Vt as the value of the fund at time t, and we have V-t as the derivative of Vt with respect to t, such that V-t is the instantaneous change in the fund value at time t. In other words, V-t is the interest earned by the fund at time t. We have V-t divided by Vt as equal to the force of interest at time t. By using this relation here, we have that V-t divided by Vt is equal to the derivative of ln Vt with respect to t. Now, if we introduce an integral on both sides, integrating from time t1 to time t2, we would end up with this relation here. Now, proceeding on with the right hand side, we end up with ln Vt2 minus ln Vt1, where ln is the natural log, such that ln of Vt2 divided by Vt1 is equal to what we have on the left hand side here. And when we introduce an exponential to cancel out the ln term, we end up with this, where the value of the fund at time t2 over the value of the fund at time t1 is given by the exponential of this integral. Now, the value of the fund at time t2 divided by the value of the fund at time t1 is simply the accumulating factor of an investment of 1 at time t1 all the way to time t2. This is such that if we multiply the fund value at time t1 by this, we would end up with the fund value at time t2. That is why it's called the accumulating factor. In a case where we are required to find the accumulating factor from a time 0 to a time n, we would simply apply this result here, such that we would plug in the times, time 0 to time n, and we would integrate the force of interest from the time 0 to time n. In a case where the force of interest is constant, we would simply end up with exponential of delta n. Now, as we saw earlier, exponential of delta is equal to 1 plus I. So the exponential of delta n is equal to 1 plus I raised to the power n. So in a case where the force of interest is constant, our accumulating factor is equal to the exponential of delta n, or 1 plus I raised to the power n. And with that, we have come to the end of Unit 3. Please subscribe to receive the next video, which is going to deal with questions and answers from the CT1 papers covering the period 2005 to 2012. Thank you very much for visiting my channel. See you soon.